Second part of the equilibrium is the explanation of the equilibrium constant and the reaction quotient. So K equilibrium and Q. Understanding how to express and interpret the equilibrium conditions is critical for analyzing chemical systems. So we can use a specific mathematical expression like that equilibrium constant, and you write it like that. K, that's for constant, and EQ, that's for equilibrium, or the reaction quotient to know what is the value exactly of the equilibrium and how can the system in equilibrium behave. So let's start with the equilibrium constant or K equilibrium. The equilibrium constant K equilibrium expresses the ratio of the concentration or the ratio of the pressure of products relative to the reactants. So I will always put the products first in the numerator divided by the denominator in the reactants. Every one of them will be raised to the power. What is the power? The power is their stoichiometric coefficient in the balanced chemical equation. So for the general reaction where the number of moles of A, any number of moles, let's say alpha, reacts with any number of moles of B, let's say B, and this is in equilibrium with products C. What is the number of moles of C? That's C small, and what's the number of moles of D? That's D small. So I will write that the K equilibrium is equal to what? K equilibrium just divides the products. What is the product? The first product is C, and this is bracket means the concentration in moles per liter. So this is the concentration in molar or mole per liter in brackets like that. And then don't forget it's multiplied by, not plus, multiplied by the concentration of D. What is the number of moles of C? It's C small, so it's raised to its power. D capital is raised to the power of its coefficient, which is D small, so D. And then I'll divide this by the reactant. So what is the reactant? Reactant is A, again multiplied by, take care, not addition, multiplied by B. So it's to the power of alpha and to the power of B. So this is the equilibrium constant. To understand this tells you exactly what is the extent to which reactants have turned into products at equilibrium. When I started with the reactants, did all the reactants change into products, or mainly the products are still very small and it's mainly reactants in the reaction, or there is an equilibrium between them? This is what the equilibrium constant tells you how much or what's the extent the reactants have turned it into products. So what are the types of the K equilibrium? There are two types of K equilibrium. Kc, this represents the equilibrium in the terms of concentration for aqueous solutions or for solutions, and Kp, and this speaks about the equilibrium in terms of partial pressure in case of gases.